I thought I would begin by giving you a review of some basic concepts in finance. Probably you're familiar with these already, but if not, you will learn something. Let's also make sure we distinguish between continuous growth models and discrete growth. And let's start with the concept of the future value of money. Okay? And let me just use V for the future value of money. Now, the future value of money will be a function of how long you let your money compound. Okay? So a V will be a function of time. Future value of money depends on how long your money is invested. And if we take this discrete model first, let's take the discrete model first. Let I be the annually compounded interest rate. As opposed to R is going to be the continuously compounded interest rate. So when you see I, that means in this course it's the annually compounded interest rate. And let A be the initial sum of money that you have. At t equals 0. T equals 0 is the present. Okay? And t is measured in years. Okay, so t is measured in years. Then the future value of money is given by this formula right here. It's A times 1 plus I, 1 plus the annually compounded interest rate, raised to the t power. Notice this is an exponential function because the base here, 1 plus I is the base. You could call that B if you wanted to. And then it's raised to the t power. So this is a simple exponential function. Just to give you a simple example, suppose A is $1,000. I'll leave off the dollar sign. Suppose the annually compounded interest rate is 0.05 or 5%. Multiply that by 100, stick on a percent sign, you convert the decimal into a percentage, so that's 5% per year. And t is the number of years. So how much would your $1,000 be worth in 1 year? So that would be V of 1. If A is 1,000, you just plug in 1,000 there, times 1.05, 1 plus 0.05, 1.05. T is 1 to the 1 power, so it's 1,000 times 0.05, or $1,050. At the end of a year, your $1,000 becomes worth $1,050. Okay. Suppose we look at the value, the future value of your money at the end of 2 years. Then it would just be 1,000 times 1.05 squared. See what you're doing? This is how much it's worth at the end of 1 year, which is this. So if you just multiply this by another 1.05, that's the same thing as squaring this. Okay? So it's 1,000 times 1.05 squared. So at the end of 2 years, this will be worth, oh gosh, I didn't, help me out here. I didn't even calculate it. What is, well, I have my calculator handy. So just take 1,050. So can somebody do this to check me? 1,050 times 1.05 equals $1,102. Wait a second. Oh, yeah, 1,102.50. Okay. Or just take 1.05, square it, multiply it times 1,000. Okay, is that what you get? Okay, all right. What would, oh, here's one I did. This is more interesting. Would this $1,000 be worth after 30 years? Okay. What would be the formula if you wanted to calculate the value of this after 30 years? $1,000 invested at 5% annually compounded interest. How much would it be worth after 30 years? Well, what would be the formula you would use for that? What is V of 30 in this case? Anybody got it? Don't be shy. Okay, so it would just be this 1,000 times 1.05 raised to the 30th power. And Sean, you got 4, 3, 2, 1. Let's round it off to the nearest penny. To the nearest penny, it would be rounded off to 9.4. Excellent. That's the same thing I got. Must be right. Okay. That shows the power of compound interest working. After 30 years, your $1,000 becomes worth more than 4 times as much. So the moral is you should start saving now for your retirement. The earlier you start, the more comfortable a retirement you will have. Okay. One of the things that's advantage of being a college teacher is they force you. They take a certain amount of money out of your paycheck every month, and they put it towards your retirement fund. So I was forced in my 20s to start saving. So now, you know, it's accumulated to be a rather nice sum. Okay. Since I've been working for, I don't know, 34 years now. So the power of compound interest. It's even more impressive if the interest rate is higher. You know, historically in the stock market, you get about, on average, 9% a year historically. So if you change that from 0.05 to 0.09, in fact, let's do that. What would it be worth if we changed this to an interest rate of 0.09 after 30 years? It would be 1,000. I wish I'd had more of my retirement going into the stock market. What would that be, Sean? So what you need to do, you are going to need to have a calculator that will calculate exponential functions like this. Diana, do you have it? 1.09 to the 30th power, then just move the decimal over 3 times, and it would be what, Diana? Oh, look at that. Oh, isn't that much better? 13,267. 68 cents. Very good. Wow. More than 13-fold after 30 years. Okay, that shows you the power of compound interest. Especially the higher that interest rate gets, the more powerful this compounding becomes. Okay. I wish, in retrospect, I'd have had 100% of my money going into the stock market. The stock market usually over long periods of time does better than the bond market. But the stock market does show more volatility. The downside of having too much money in the stock market is that all of a sudden you're about to retire and the stock market crashes and loses 50% of its value. Could happen. So that's a downside. Okay.